Students, welcome to IMS Academy. Myself Sandeep Adari. See, my dear students, in this today's session, I'll be covering you the problems on the transportation engineering. In transportation, if you ask me, there are three important concepts. One is related to what, sir? One is related to the most important thing is traffic engineering. Second one is the geometric design. In geometric design, we'll be discussing about the stopping side distance, overtaking side distance, super elevation, extra widening, and similarly, my dear students, if you talk about the concepts in airport engineering or corrections or some of the problems on railway engineering. So my dear students, if you see the weightage in transportation in GATE exam, it varies from 8 to 10 marks or sometimes it can be 8 marks also. So my dear student, it is a very important subject for scoring good marks in GATE exam. So I don't want to waste your time. Quickly we'll go into the concepts where we can discuss the problems. So here I have the first question for you. So please read the question. The free mean speed is 60 km per hour on a road. The average space headway at jam density is 8 meter. For a linear speed density relation, the maximum flow expected on the road is. This is one of the beautiful questions, sir. So my dear students, if you consider here, see. If you consider here, let us see here. He is telling that speed and density varies what, sir? Speed and density varies linearly, okay? Here what he has told, speed and density varies linearly. So my dear students, when I talk about speed and density varying linearly, so how will be the graph? Okay, just a second. So here please understand, my dear students, I hope I am audible. Here if you see, the speed versus density relation varies in a linear way. So my dear students, if you see from this, if you derive, V can be written as Vf into 1 minus K upon Kj. And this formula can be derived using the straight line equation, y is equal to mx plus c. So if you know y is equal to mx plus c, straight line equation, from that we can derive v is equal to Vf into k upon kj. Now my dear students, what is Vf? Vf is nothing but the free flow speed. What is Vf, sir? Vf is nothing but the free flow speed. Similarly, my dear students, if I talk here, what is kj? Kj is nothing but the jam density. What is kj, my dear students? Kj is nothing but the jam density. So my dear students, if you see the question here, they have given you clearly what is the free mean speed. So free mean speed is how much, sir? 60 km per hour. So they have given you, 1 second students, they have given you free mean speed is how much, students? They have given as 60 km per hour. Now please understand, students, they have given you the space speed. Means if you see here, for a linear speed, the space headway is how much, sir? 8 meter. I hope you are clear, my dear students. So when I talk here, space headway is given as 8 meter. And this 8 meter is at which place, sir? Remember, my dear students, this is the value which is given at jam density. This is the value given at jam density. So my dear students, if I consider here jam density, at jam density the space headway is 8 meter. So to calculate jam density, K can be written as 1 upon space headway. But let me tell you, space headway, if it is in kilometer, then you can write it as 1 upon space headway. But here it is given in meters. So my dear students, we substitute 1000 upon 8. You get the jam density value as 125 vehicle per kilometer. And remember, my dear students, the basic relation, what actually is traffic flow? The number of vehicles crossing a section per unit time. So the vehicle per hour is nothing but the, you can say, vehicle per hour is nothing but the traffic flow, and vehicle per length is nothing but the traffic density. So you know the jam density, you know the traffic flow, free flow speed. Now my dear students, the maximum traffic flow, if I consider you the maximum traffic flow, and let me tell you, my dear students, this is a very important equation and we can expect a very important problem from this. So Q max can be taken as Vf into kj by 4, and this formula has been given by the green shield model, where the velocity and density varies linearly and the flow and the density also varies parabolically. So my dear students, when I take Qmax, the maximum traffic flow, so what is the Vf value we here? Vf value we got is 60. Very good, my dear students. So try to reply in the chat box, my dear students. Are you following or not? So here we have the jam density, which we calculated as 125 divided by 4. So my dear students, it will be 125 into 60 is roughly around 7,500 divided by 4. So my dear students, if you solve this, you will get a value of 1875 vehicle per hour. So I hope this solution will clarify your doubts on the green shield model. So my dear students, what is maximum traffic flow? It is nothing but the flow, or you can say maximum traffic flow can be also the capacity condition. If they give you the capacity condition also, you just try to find out the maximum traffic flow. If you solve the problem in this way, definitely you will have high chances to solve the problem in the right way. Okay. Now my dear students, let us go into the second question. Here you should be again careful. So first of all, whenever you are reading the gate question, I would suggest you to read the question carefully. Reading the question will help you to understand what is the key point or what is the learning in that. So let us give you, I'll give you some, sir, see. 1 second students. Let me show you the clock. Okay. So I'll give you 2 minutes of your time. So please go through the question. So I want everyone to go through the question, my dear students. So just go through the question, and if you can read the question, it will help you. Okay. Students, I hope you are solving the problem. Okay, I have given you enough time, students. Now see, the figure represents the trajectories of the vehicles within the time's main speed. The numbers in the parentheses represents the unit identification of the each vehicle, the mean speed of the vehicle in the entire time speed. So here, my dear students, what is entire time mean speed? So what is entire time mean speed, sir? Entire time mean speed is nothing but the average here. So you can take sigma I is equal to 1 to n Vi upon number of vehicles. Are you getting me? What is the time mean speed, sir? You just take the average of the speed of the vehicles. Now let me tell you what is velocity, my dear students. Here, what do you mean by velocity, sir? Velocity is nothing but distance upon time. What is velocity, sir? Velocity is nothing but distance upon time. So my dear students, see, if I talk here, if I see here, so if you see, this is the one which is the first one, and here we have. Now what is the distance, sir? Distance is on y-axis. On x-axis we have what, sir? Time. So my dear students, if you see for graph 1, if I take graph 1, what is the distance here? 500. And what is the distance here? 400. So remember, my dear students, the slope of the distance and time graph will give you the velocity. So here I can write 500 minus 400 is the distance travel upon what is the time, sir? Here time is 10 and here we have the time is 0. So 500 minus 400 upon 10 minus 0. So for the graph 1, what is the velocity you will be getting, sir? You will be getting you 10 meter per second. Why 10 meter per second? Units are also very important, my dear students. On y-axis we have meters, on x-axis we have seconds. So please write down the velocity for the graph 1 is what, sir? It is 10 meter per second. Similarly, my dear students, if I talk about the velocity in the second graph, suppose if I have taken the second graph, here the distance is 500 and here the distance is 250. So find the difference between them. You can say that the velocity is equal to 500 minus 250. And what is the time here? If you consider the line 2, the time has 15 seconds and it is having 0. So 500 if 250 minus 15 minus 0. So my dear students, it will be 250 divided by 15. So roughly we can say it is equal to 16.66 meter per second. I hope you are clear. So please write down this equation, my dear students. Matan, good afternoon. So please write down this, sir. Please write down, please reply, students. Okay, so very good. Similarly, see students, for velocity V3, I'll do for the velocity V3. So here what will be the velocity, sir? For velocity for 3 line, here the distance is 500 and here the distance is 100. And if you see the difference also 30 minus 0. So if I take velocity V3, it is 500 minus 100 upon 30 minus 0. So it is around 400 by 30. What is the value? Please respond, my dear students. This will be equal to 13.33 meter per second. Okay. Similarly, my dear students, we have line V4. So what is V4 here? So it is the line V4. Here the distance is around 400. And if you see, the distance here is 0. And if you see 30 and the time is 5. So 400 minus 0, you can say 400 minus 0 upon 30 minus 5. So my dear students, you can get a value of velocity of V4 is how much, sir? 16 meter per second. Am I clear, students? So we get a value of 16 meter per second. Similarly, if I take V5 here. So my dear students, what is V5, sir? Here please understand, here it is having a distance of 350 and here it is 0. So my dear students, 350 minus 0 upon the time is what, sir? 30 minus 15. So it will be how much, sir? Around 23.33 meter per second. Am I clear, my dear students? So just finding the slope, you will get the velocity. Similarly, if I talk about the velocity at V6. So if I talk about the velocity of the 6th line, sir, what is the value here? Here the value is 150 and here is 0. So the slope is what, sir? 150 minus 0 and 30 minus 20. So you can write velocity of 6 is 150 minus 0 upon 30 minus, what is the value, sir? 20, I think. 30 minus 20, right? So 30 minus 20, you get a value of 15 meter per second. Now what we have calculated? We have calculated the individual velocities, that is V1, V2, V3, V4 and V5, V6. Now what we have to do, sir? See, just we have to get the average time mean speed. which I have told you, sigma I is equal to 1 to n, Vi divided by n. So n is nothing but the number of, like you can say, number of vehicles. So initially 1 and 2 we have, what is the value, sir? 10 and 16.66. So my dear students, 10 plus 16.66 plus, what is the other value? V3 we have 13.33. We have the value as 13.33 plus, we have V4 16. 16 plus 23.33 plus 15 divided by 6. My dear students, it will be equal to some 30, 40, 56. 56 you can say 71. 71 and it is equal to how much, sir? 94.33 divided by 6. So my dear students, it will be around 15.7 meter per second. So the final answer here will be equal to how much, sir? 15.7 meter per second. If they ask you the value in kilometer per hour, sir, here we are not converting kilometer per hour into meter per second. We are converting the meter per second into kilometer per hour. So you just multiply 15.7 into 18 by 5. 18 by 5 will be around 3.6. So 3.6 into 15.7. It will be 45, around 47.1, and it will be around 56. You will get the answer. So if they ask you in kilometer per hour, just multiply it 18 by 5. I hope you are clear. So what is the key point in this learning is, you should understand whenever there is a graph given between distance and time, if you find the slope, you will get the velocity, and through the velocities, individual lines, take the average. My dear students, in average speed, we have two things. One is the time mean speed, and other one we have is the space mean speed. When I talk about the time mean speed is nothing but the average of the velocities. When I talk about the harmonic speed, or we can say space mean speed, it is nothing but the harmonic mean, or we can use the formula n is equal to sigma I is equal to 1 to n, 1 upon Vi. So I hope you are clear with this concept. Now this is one other important question, my dear student. So how to solve this question, let me tell you. So if I talk about the, see, I'll give you 2 minutes of time. So here please understand the consolidated data of a spot speed study is given. They have given the speed ranges from 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to, similarly they have given up to 100. They are asking what is the upper speed limit. So please calculate this value, and I'll give you 1 minute of time. Thank you, Saurav sir. Thank you. So my dear students, whenever these kind of questions are asked, you should be careful here, my dear student. What you should be careful here is the simple thing here. Now my dear students, when they ask you the lower speed limit, see my dear students, when they ask you the lower speed limit, okay, when they ask you the lower speed limit, you have to find out at 15 percentile. There is a graph between cumulative number of vehicles and the velocity. At the 15th percentile, we take it as the lower speed limit. I hope you are clear. Very good. Similarly, my dear students, they will give you the median speed at 50th percentile. At median speed, if you want to find out, you will calculate at 50th percentile. Very good. Now, my dear students, in this problem, they have asked you the upper speed limit. This is a very tricky thing because we are habituated. Upper means we will take the maximum value. But upper speed limit is given as 85 percentile, my dear students. And my dear students, if I talk about the design speed is at 98 percentile. So what is the design speed? The design speed is at 98 percentile. So whenever you are solving a problem, this concept, in and around concept, will help you to solve more and more problems. So my dear students, when they give you the 15th percentile, it is the lower speed limit. If they give you the 98th percentile, that is the geometric design speed. If it is the 85th percentile, Let me tell you, my dear students, the 85th percentile is you can say the upper speed limit. And here, my dear students, let me tell you another important thing. The 98th percentile is the geometric design speed. So, my dear students, in this question, they have asked you the upper speed limit. So, what is actually the upper speed limit? So, the upper speed limit is nothing but the 85th percentile. So, let me draw the graph here. Let me do the, 1 second students, just a second. Okay. So, let me go to the, here we will draw the 731. Let me draw the equations, sir. The question here, we have 7, 31, 76, 129, 104, 78. 129, 104, 78. These are what, sir? These are the number of observation. 29, 24, 13, 19. 29, 24, 13, 9. See, my dear students, here they have given you the number of observations. Here what they have given you, sir? They have given you the number of observations. Now, my dear students, here you should understand what is the speed range they have given. The speed range is given as 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, and we have 60 to 70, 70 to 80, 80 to 90, and we have is 90 to 100. Now, my dear students, please understand here I am not doing any rocket science. This is the given data. So, just try to sum up all the observations. First, find all the summation. 7 plus 31, 38, 38 plus 76, it is around 114. 114 plus 129, it is 243. 243 plus 104, 347. 347 plus 78, it is around 425. 425 into plus 29 is 454. 478, 491, 500. So, if you consider here the summation, my dear students, the summation value is 500. I hope you are clear. Now, my dear students, when I calculate the summation, now it is the percentage finding. You have to find out the percentage. Now, percentage of observations is what, sir, you can say. You have to find out the percentage of observations here. So, you can write here 7 by 500 into 100. Why? Because the total value is, the sum of the observations is 500 and we have the percentage calculation. So, you can say, my dear students, here it is 1.4 percentile. So, 7 by 5 is 1.4. If you talk about 31, if you do the similar thing, it will be 6.2 percentile. 76 will be 15.2 percentile. 129 is around how much, sir? It is 25.8 percentile. If I talk about 24, it is 20.8 percentile. If I talk about 78, it is 19.6. 29 is what, sir? 5.8. 24 is how much? 4.8. 13 is how much? 2.6. And 9 is how much, sir? You will get the value as 1.8 percentile. So, these are all about the percentages. Now, what I have to do? I have to calculate the cumulative. The next important task I will be doing is the cumulative part. So, my dear students, when you ask me the cumulative part, just add the step by step all the percentage observations. So, my dear students, if you consider here, this value is equal to the 1.4 and here it will be equal to 7.6 and after that it will be 22.8 and 22.8 plus 24.8, it will be how much, sir? 47 and 48.6 if I am correct. So, it will be equal to 68, 68 and 69.4 plus this value will be equal to how much, sir? Am I correct, sir? So, 71.4. So, first we have 1.4, 7.6, 22.8 and next one what we have, sir? 48.6, 48.6 plus 20.8 is how much, my dear students? What is this value? 69.4. Now, this value here it is how much, sir? This is 20.8, right? This is 20.8 and this is 15.6. This is how much, sir? 5.8. So, here if you add 15.6, you will get a value of 85. What is the value, sir? You will get a value of 85. So no need to proceed. Remember, my dear students, no need to proceed here. Why? Because we want only 85th percentile. What they have asked you? They have asked you only the geometry. They have not asked you the geometric design speed. They asked you the upper speed limit. So here they have asked you the geometric design speed, which is equal to, here I am writing this, sir. This is the value which you will get. So my dear students, at 85th percentile, you can say 50 to 60. So the answer here will be 50 plus 60 by 2. You have to take the average. That will be equal to 55 km per hour. So what is the upper speed limit if they ask you? The answer is 55 and the option is B. I hope you are clear. Sir, just you have to make a table kind of stuff. You have to calculate all the values in percentages. Similarly, you have to consider the cumulative value. Once you got the cumulative value, at the 85th percentile, you will be taking the upper speed limit. So once again, I am giving you the entire details. At 15th percentile, we will take the lower speed limit. At 85th percentile, we will take the upper speed limit. At 98th percentile, we take the geometric design speed. And let me tell you, at 50th percentile, we take the median speed. I hope you are clear. So let me go to the next question, my dear students. So the question here is, a plot of speed density relation was given in the question. And they are asking if the capacity of the road of CA and CB is given, what is the ratio of CA upon CB? So quickly, I will give you 1 minute of time, my dear students. Please try to solve this question. Very good, sir. Okay, my dear students, see, if you understand here, my dear students, there is a model called green shield model. What is the model here, sir? We have a green shield model. Okay. In green shield model, what is the relation between velocity and density, sir? I told clearly in green shield model, velocity versus density varies linearly. What is the relation between velocity and density? The velocity and density varies how, sir? It varies linearly. Now let me tell you, my dear students, they have asked the capacity. To find out the capacity, sir, it is nothing but the maximum traffic flow condition. To find the capacity, you should understand what is the maximum traffic flow condition. What you have to understand, sir? You have to understand the maximum traffic flow condition. So here, what is the maximum traffic flow condition, which you are already aware? So it is nothing but Q max is equal to Vf into Kj by 4. Okay. Now you can ask me, suppose if I have a graph here, if this is a graph between velocity and density, my dear students. If this is a graph between velocity and density, we know this varies linearly. So this we call it as free flow speed, and this we call it as the jam density. So what is the maximum values of the velocity and density will be considered as the free flow speed, or we can say the jam density. So from the graph, it is evident or clear that the maximum values are UA and KA, UB and KB. So my dear students, they are just asking the relation here. So it is nothing but CA upon CB. And always remember what exactly is the difference between capacity and flow. Flow is nothing but the vehicles per hour. Capacity is nothing but vehicle per hour per lane. But in capacity, we take the maximum traffic flow condition and we will calculate the capacity. Once you calculate the maximum traffic flow and per lane, that will convert it as a capacity. So here it is evident clearly that it can be written as mu A Ka upon 4 divided by UB into KB, where these are the free flow speed and jam density is divided by 4. So if I cancel 4, the final answer here will be UA into KA upon UB into KB. So my dear students, let me tell you once again, I challenge in this YouTube platform that green shield model and traffic engineering, we can expect 100% 2 marks question in the GATE 2025. So please, my dear students, when you are preparing the GATE exam, traffic engineering in transportation, this green shield model or time mean speed or space mean speed concepts are very important. So let us quickly go into the next problem. So please read the question, my dear students. I'll give you 1 minute of time. Okay, my dear students, I have given you enough time here. So, my dear students, here the question is, consider 4 points PQRS in the green shield model, denote their corresponding traffics, and what is the correct order of the densities. So, let me draw one important graph which you will be understanding related to the green shield model, my dear students. As I told you, if you consider here, if I take the velocity density relation, this one, and see, they have given the relation between what, sir, and speed and flow also. Okay. Now, my dear students, if you see the graph here, the given data says that the speed, this is what, sir, this is the relation between the speed. I represent speed with velocity and I represent the flow with the q. Now, my dear students, let me tell you, the velocity and density in green shield model, you should be aware and you should highlight this point. The velocity and the density relation in green shield model varies linearly. So, my dear students, if I talk here, see, the relation will be in this way. Okay. Now, my dear students, see, they have given different points, so we correlate them here. Okay, with the densities. So, I am just correlating here. Okay. Now, my dear students, this is a graph drawn between velocity and flow, and this is a graph drawn between velocity and k. So, how can I compare these two graphs? On y-axis, see, in both the graphs, the velocity is the same. So, I could compare directly. So, they have given the notations here as this one is S, this one is R, this one is Q, this one is taken as P. Now, let me compare this linearity. So, density at this point is 0, it is slightly higher than that point. Okay. If you talk about S, R, Q and P. So, from the diagram, it is evident that the density at P is more. So, my dear students, if I talk about the densities, you can say Kp is greater than, Kq greater than, Kr greater than, Ks. So, this is the final answer for you, my dear students. So, let me tell you, my dear students, if you have the density relations, then this will help you. So, my dear students, green shield model is a serious topic in traffic engineering. So, again and again I am stressing you, my dear students, these model problems will somewhere, if there is no question in traffic, but this concept will be somewhere related. So, that is the reason I have given you this problem. Now, my dear students, sorry. Now, see, read this question. There is another beautiful question here. So, you can read this question here. So, my dear students, here I am reading the question for you. A two-phase signalized intersection is designed with a cycle time of 100 seconds. The amber and red time are 4 seconds and 50 seconds. If the total lost time for phase due to startup and is 2 seconds, what is the effective green time? So please solve this problem. So very good, my dear students. First of all, let me tell you here, very important thing. The important thing here is, first of all, you should understand what is optimum cycle length. Optimum cycle length is nothing but the summation of green time plus amber time plus red time. Again, my dear students, in a signal concept, we have G is what, sir? Green time. And A is called what, my dear students? This is called the amber time. And what is R? R is nothing but the red time. So my dear students, when they give you the optimum cycle length, it is nothing but the summation of green time plus amber time plus red time. So they have given you clearly it is 100 seconds. Now let me tell you, my dear students, they have given you for each phase, the amber time is 4 seconds and the red time is 50 seconds. So let us find out here, G plus amber time is how much, my dear students? It is 4 seconds. And the red time is how much? It is equal to 50 seconds. Now, my dear students, what will be the green time, sir? Green time will be equal to 46 seconds. What is the green time, sir? Green time is equal to the 46 seconds. Am I clear or not? Very good, very good. Now, let me tell you what is the effective green time. So, effective green time is nothing but green time plus amber time minus lost time. What, sir? Green time plus amber time minus lost time. So, my dear students, you know already the green time, you know already the amber time. So, green time is how much? It is calculated as 46 seconds. Now, what is amber time, my dear students? 4 seconds. And they have given you the lost time is 2 seconds. So, if you see here, they have given you the lost time per phase due to startup and clearance is 2 seconds. So, if I just plug in those values in the formula, I get the effective green time is nothing but the 48 seconds. So, my dear students, what is the key contribution for this problem? The key contribution for this problem is the optimum cycle length is a summation of green time plus amber time plus red time. And when the word, the effective comes into picture, you should remove the lost time. So if you can take these two key points into the concept, then definitely these kind of problems can be solved. I hope you are clear. Very good, very good. Now, there is another question here. At a traffic section, cars and buses arrive randomly according to the independent Poisson's process at an average rate of 4 vehicles per hour, 2 vehicles per hour respectively. The probability of observing at least 2 vehicles is 30 minutes. So, my dear students, you name in mathematics also. If you name mathematics also, here, there if you observe, Poisson's distribution plays a very important role in the probability concept. So, my dear students, please understand the question here. And let me tell you, in Poisson's distribution, and keep this as an important note, if the number of vehicles are not mentioned, what, sir? If the number of vehicles are not mentioned, you have to assume the number of vehicles as 0. So, please add this point into your notes if it is not mentioned in your notes. So, what is the key point, sir? If the number of vehicles are not mentioned in Poisson distribution, you have to assume that number of vehicles as 0, and the vehicle arrival rate is nothing but the lambda, and you know the formula I will be giving you. So, please read the question. Very good, my dear students. I have given you the enough time. Now, let me tell you, my dear students, Here, if I talk about the probability of n number of vehicles and time t, if I talk about the probability of number of vehicles and time t, so what is the formula here we have, sir? It is given by the formula e power minus lambda t into lambda t power n upon n factorial. Okay, here my dear students, please understand what is lambda, sir. Lambda is nothing but the vehicle arrival rate. These are very, very important, my dear students. Sir, what is lambda? Vehicle arrival rate. So, in the name itself, what is the term, sir? Vehicle arrival rate. So, how many vehicles are arriving in a time t? So, it is nothing but something related to units, can be vehicle per hour or vehicle per second, or it can be vehicle per minute based on the given data. Now my dear students, please write, because again you will think it is velocity. So write. Now here let me tell you, my dear students, see, this is very, very important observation in this problem. When I multiply lambda multiplied by t, lambda units are in vehicle per minute, suppose. So time should be also, it should be in minute. Are you getting me? If suppose time is in hours, so lambda should be in vehicle per hour. Suppose if time is in seconds, lambda should be in vehicle per second. So this is basic maths where you should take care, my dear student. So here they have given two vehicles. One is moving at 4 vehicle per hour, another one is moving at 2 vehicle per hour. So they have given 30 minutes. So I'll make it in vehicle per minute. So there is a lambda 1 given here, 4 vehicle per hour. And lambda 2 is given how much, sir, my dear students? 2 vehicle per hour. So there can be n lambdas. There can be different combination of vehicles. But you have to take the summation to calculate the total number of vehicles arrival rate. So here if I take lambda, this will be equal to 4 plus 2. It can be n. You have to just summation. So 4 plus 2 is how much? This is equal to 6 vehicle per hour. Now my dear students, how do you calculate the number of vehicles per minute? So the number of vehicles per minute is nothing but 6 divided by 60 minutes. So this will be equal to 0.1 vehicle per minute. So what is the vehicle arrival rate? According to the units of vehicle per minute, it is equal to 0.1 vehicle per minute. So my dear students, they have given you how many number of vehicles, sir? The probability of observing at least 2 vehicles in 30 minutes. This is very important. The probability of at least 2 vehicles, that means it should be n greater than or equal to 2 and time is 30 seconds. Sir, if you know the probability concept, he is asking, suppose if the series is between 0 to 100. So whatever the values which come across more than 2, at least means more than 2, you have to do all the combination. So here what I know, the probability of the entire function is 1. Okay, from 1, if I remove the probability of 0 and the probability of 1 vehicle, then you can get this answer. So I can write it as probability of 0 vehicles in a time 30 seconds minus the probability of 1 vehicle in 30 minutes, sir. Sorry, it is 30 minutes. This is 30 minutes. So my dear students, what is the generalized equation for our Poisson's distribution, sir? What is the generalized equation? You told here, P of n comma t is equal to e power minus lambda t power n upon n factorial. Am I correct or wrong? Very good, very good. See students, try to respond in the chat box. So here, what is lambda, sir? It is nothing but 6, right? Because 0.1 vehicle per minute, right? If I got 0.1 vehicle per minute. So 0.1 into 30. This is the lambda t. Similarly, my dear students, 0.1 into 30 power n is how much, sir? 0 upon 0 factorial. So it will be equal to e power minus 3. So if I take here, what is the values I have taken, sir? Here I have taken n is equal to 0 and time as 30 minutes. Okay, similarly what I have to do? Now I have to do for n is equal to 1 and time is equal to 30 minutes. So my dear students, if I take here e power minus lambda t is 0.1, into 30. So here what will be this value, sir? 0.1 into 30 power 1 upon 1 factorial. Am I correct or wrong? So this value will be equal to 3 into e power minus 3. So on substituting this or plugging these values into this equation, 1 minus e power minus 3 minus of 3 into e power minus 3, which is equal to, can anyone respond, sir? 1 minus 4 into e power minus 3. So if you want to do this calculation, you can do. Sir, everyone try to make a habit of using the virtual calculator because it will create a significant difference in your exam. So that is the reason even in the test series solving, I would always recommend you to go with the virtual calculator. Okay. One second, students, sorry. Minus 3, right? One second, let me check. What is the e power minus 3 value, sir? Just a second. So if you solve this, you will get a value of 0.8, okay? Just try to use the virtual calculator and try to solve the problem. Now this is another important question, sir. The vehicle count obtained in 10-minute interval. What is the vehicle count, sir? It is observed in 10-minute interval for a traffic volume survey. Okay. Now he is asking what is the peak hour factor. Now in this case, my dear students, I will give you a generic formula where you can solve any problem with a peak hour factor. Usually the, sir, peak hour factor will be less than 1. So my dear students, the vehicle count obtained in every 10-minute interval of a traffic volume survey, then peak 1 hour is given below. What is the peak of 1 hour factor for 10-minute subinterval is. So please solve this problem. So I hope you are clear with this concept, my dear students. So let us understand what exactly is peak hour factor. So my dear students, what do you mean by peak hour factor, sir? Sir, in a problem when you are solving, try to solve the problem in the most generic way. So whatever the values they have given you, if you can learn the concept in a generic way, definitely you can have high chances to convert the problem into 100% correct. So here the peak hour factor is given by the formula total hourly volume. What, sir? It is nothing but the total hourly volume. Sir, peak hour factor will not have any units. You name any factor, it will not have any units. That factor is introduced to overcome some issue. So here peak hour factor is something related to the traffic survey. So what is the total hourly volume divided by? So we have different velocities, right, sir? We have the different velocity, or we can say vehicle count, vehicle count. So here vehicle count, maximum vehicle count. Okay, now multiplied by, okay, time interval is also given, sir. Maximum vehicle count multiplied by, sir, here you should understand 60 divided by the time interval. 60 divided by the time interval. So here what is the time interval, sir? You can say the time interval is 0 to 10 minutes. So you can, because why I have introduced 60 per 1 hour, there are 60 minutes. The time interval is how much, sir? You can say the time interval is how much? 10. So here what is the total hourly volume, sir? So count all the values, my dear students. Here you just count the total hourly volume means you have to count all the vehicles. So 10 plus 11, 21, 21, 12, 33, 48, 48 plus 31, it is 61, 61 plus 11, it is 72. So the total hourly volume is how much, sir? It is equal to 72. Am I correct or wrong? Very good, my dear student. So here the total hourly volume is 72 divided by Vmax. What is the Vmax value, sir? Here if you see the vehicle count, 10, 11, 12, 15, 13, 11. What is the maximum vehicle count? Here vehicles, sir. Don't compare with velocity. So the maximum vehicle count is how much, sir? It is 15. Multiplied by the time interval is how much, sir? 0 to 10 minutes. So it is divided by 60 divided by 10. So my dear students, what is the time interval we have? 0 to 10. 10 to 20, 20 to 30, 30 to 40, 40. So what is the time interval here we have? 60 to 10. So please do the problem. How much you will get, sir? How much is the time interval we have? So it is nothing but what, my dear students? It is nothing but 72 divided by 90. So the factor here is equal to 0.8. What is the factor we have, sir? The factor is here is equal to how much? 0.8. So please write down this solution. Now, my dear students, please try to solve this. I'll give you 2 minutes of time. Okay, please read the question, students. Please read the question. So, my dear students, here we have a beautiful question for you. Am I audible, sir? Yes. The question here is simple. Amma. Assume the traffic on a highway obeys the green shield model. The speed of shock wave between two traffic streams, P and Q. So, my dear students, here they have given you the flow is how much, sir? Here they have given you the flow is how much? The flow is nothing but 1200 vehicles per hour. So, what is the flow they have given you? 1200 flow vehicles per hour. Let me tell you, my dear students. And in the next one, they have given you the speed. These are the values for P. And the speed is given as how much? 60 kilometer per hour. And here, if you talk about the next case, what is the other thing we have? Q. So here, what is the flow, sir? Here the flow is 1800 vehicle per hour. And what is the speed here we have? And here the speed is how much? Speed is nothing but the 30 kilometer per hour. What is the speed, sir? 30 kilometer per hour. Okay. Now, my dear students, let me tell you, if there is a graph drawn between flow and density. What, sir? If there is a graph drawn between flow and density. Are you clear, my dear students? The graph between flow and density varies parabolically, which you all know. But they have asked you the concept that is shock wave. They have asked you the concept, it's a shock wave. Shock means what? Sudden change. Actually, my dear students, here what do you mean by shock wave is, a shock wave is nothing but the sudden change in traffic volume, or you can say, my dear students, sudden change in traffic density. What is the concept of shock wave? A sudden change in the traffic flow or sudden change in the traffic density. It can be a monolithic increasing or monolithic decreasing, or sudden change in traffic flow, or you can say traffic density. Now, my dear students, if I ask you here, I am giving you the in and around concept. So here, if there is a point A, suddenly it will drop here, or suddenly so suppose if I take a point A here, or here they have given you PQ, right? Suppose if this is the case, okay, if somewhere here it is increasing. So here the flow is increasing, here the flow is decreasing. So what actually is shock wave? To find out the shock wave, see students, to find the velocity of shock wave, you can say dq by dk is nothing but the velocity of the shock wave. So this is the important formula. See, you know already, my dear students, q is equal to what, sir? K into v. Here velocity can be written as what? Q by k. But here why we are taking dq by dk? It is change. Sudden means there is a change. And if I consider this point at this point, we consider this point as the stationary point, because there you can say that the flow is maximum, or if you consider dq, there will be no change because it hits at one point. So there will be no change. So here if I take dq by dk, so you know already the values, that is 1200, p and 1800. So my dear students, to find out the velocity, it is nothing but 1800 vehicles per hour minus 1200 vehicles per hour. Similarly, we have, what is the speed, sir? 1800 and speed is 30. So here we see, observe my dear students, you know q is equal to what, sir? K into v. So velocity can be written as q by k. So one is what, sir? 1800 divided by, if I take this is for q, 1800 divided by density is how much, sir? 30. So it will be 60. Okay, similarly they have given you another one is 1200 and the speed is, if they take the velocity of p, 1200 is the density, flow, and density is 60. So here the velocity is 20 vehicle per hour. Here the velocity is how much, sir? 20 vehicle per hour. Here it is 60 vehicle per hour. Here it is how much, sir? 20 and 60. So I will substitute here 60 minus 20. So here the velocity is 15 kilometer per hour. So my dear students, the velocity of the shock wave is given by the formula 50 kilometer per hour. And let me tell you, the velocity of the shock wave, the key point for the velocity of the shock wave is dq upon dk. At a stationary point, the flow is maximum. So any queries in this problem, my dear students? Any queries in this problem, my dear students? Any doubts in this? Very good, very good. Next, see this question, sir. What is the question here is, the lane configuration with lane volumes in vehicle per four-arm signed intersection. There are only two phases. The first phase for the east-west. Please solve that problem, students. I would be very happy if you solve the problem and reply the answer in the comment box. Okay, please solve that, my dear students. Please try to solve the answer here. Now see students, there was a method called Webster method. What is the method, sir? We have a method called Webster method. Sir, in this method, Webster method, sir, what is optimum cycle length is? Please listen here carefully, my dear students. If I consider what is the optimum cycle length is, if they have drawn a graph between average delay per vehicle and time. This is average delay per vehicle, okay? And this is time. Sir, optimum cycle length means where the delay is minimum. Where the delay is minimum, we call it as optimum cycle length. We call it as what, sir? Optimum cycle length. Okay. Now, my dear students, I hope you are following. Here, what is optimum cycle length? Here, C0 is given by the formula 1.5 L plus 5 upon 1 minus y. This is the formula. Sir, what is L here? This is taken as total lost time. What is L, sir? L is given as total lost time. Sir, here total lost time is taken as N into TSL plus TCL. What's sir? TSL plus TCL. Now what is TSL here? It is the startup loss time. This is what, sir? This is the startup loss time. Agree? What is TCL? This is the clearance loss time. This is the clearance loss time. Now, my dear students, what is N? N is nothing but the number of phases. Okay. So, here this formula can be modified as L is equal to 2N plus R. What, sir? It can be modified as 2N plus R. What is N here? N is the number of phases. N is what, sir? Number of phases. What is R here? All read time. Okay. Now, my dear students, you should also know what is Y here. Y can be written as summation of the flow ratios. Y2 plus Y3 plus so on up to based on the number of phases. Now, what is summation of flow ratios? What is Y1? Y1 is again written as Q1 by S1. What is Q1 by S1 here? Q1 is the normal flow. And what is S1, sir? S1 is the saturation flow, or you can say maximum flow, or better. So, it is the summation of the flow ratios. So, my dear students, I have given you the complete idea what actually is optimum cycle length. It is the time at which the average optimum cycle length is considered where the delay is minimum. Okay. So, we have given the formula here. Now, let us understand the problem here in this problem. So, the problem here is they have given you some values. Okay, they have given you the values. If I take the north-south direction, what is the maximum value we have? You always have to take the normal flow maximum. This is 396. Okay. If I consider here, what is the maximum flow? It is nothing but 504. But let me tell you, they have given, assume the saturation flow as 1800. What is the saturation flow? 1800, my dear students. You have to assume the maximum saturation flow is how much? 1800. So, my dear students, similarly, they have given what is the loss time, sir? The total loss time for the first and the second phase is given as 9 seconds. So, no need to calculate for each phase. For the first phase and the second phase, they have given the values as 9. Now, my dear students, if I talk you here, what is the optimum cycle length? So, my dear students, when I talk about the optimum cycle length, it is given by the formula 1.5 L plus 5 upon 1 minus Y. So, my dear students, here what is the total loss time given in the problem? See, my dear students, what is the total loss time given in the problem? So, the total loss time given in the problem is 9 seconds plus 5 upon 1 minus Y. What is 1 minus Y, sir? 1 minus Y can be written, there are two phases. So, we have got Y1 plus Y2. Here, what is Y1, sir? Y1 can be written as 396 upon 1800. And Y2 in the east-west direction, it is taken as 504 upon 1800. So, these are the values which are saturation flow 1800 is given in the problem. But 396 and 504 are calculated the maximum values from the signal intersection diagram. So, here you can write 396 upon 1800. So, this is the first Y1, flow ratio of signal phase 1. Next one we have the phase 2 is 504 upon 1800. So, my dear students, you can think, sir, why you have not done Y1 plus Y, individual values and Y? Because there is a calculation easy. If I add 396 plus 504, it will get 900. So, now LCM is, denominator is same. 900 by 1800 is 0.5. So, 1 minus 0.5, it is 0.5. 13.5 plus 5 is 18.5. 18.5 divided by 0.5 is nothing but the 37 seconds. So, my dear students, the final answer we have is the 37 seconds. I hope you are clear. I hope you are clear. So here the most important thing is, what is y, sir? It is the summation of the flow ratios. The key point for this problem is you have to find out the maximum flow, that is Q1 in the problem. Very good, very good. Sir, this is also related to green shield model. So in a road, the speed density of a traffic stream is given in the problem. Okay, so please, I'll give you 1 minute of time, as we have done n number of problems also in this. In today also I have done 2-3 problems, and this is the one of the important topic I can say you, sir. I hope you are clear, my dear students. I have given you enough time, Amma. On a road, the speed density is given by U is equal to 70 minus 0.7 k in vehicle per hour, and the capacity condition, the average time headway will be. Now see students, whenever these kind of questions are given, see, you should always remember that speed versus density varies. Speed versus density varies linearly according to which model, sir? According to the green shield model. So here V, velocity, can be written as Vf into 1 minus k upon kj. What, sir? Vf is equal to 1 minus k upon kj. Now let me tell you what is Vf here, sir. Vf is nothing but what? Free flow speed. What, sir? Vf is nothing but the free flow speed. I will do in a two-way also. And here what is kj, sir? Kj is nothing but the jam density. Okay. Now my dear students, you can simulate the equation given in the problem with the same concept. You can say U is equal to, they have given 0.7 minus 70 k, sir. This is the formula. What is U? Velocity. So if I take 0.7, we can take 0.7 into 1 minus, sorry sir, I think 70. U is equal to 70 minus 0.7 k. What is the equation given, sir? U is equal to 70 minus 0.7 k. This is the equation. So here what I would like to tell you here is, take 70 as the common. You form the equation in this format. I will tell you in another easiest way also, sir. Let me tell you. If I take common here, 70 into 0.7 by 70 into k. Similarly, you can write it as what, sir? You can write this equation as 70 into 1 minus k upon 70 by 0.7. This is what? Kj. Are you clear? Very good, very good, Vinay Alvarpu. Very good, Vinay Alvarpu. Sir, see, very good, sir, very good. So here, if I take what is Vf, sir? What is Vf? 70 amma. Okay, what is Kj? From this, Kj is equal to 100. Am I correct or wrong? Very good. Am I correct, sir, Vinay? So what is Qmax? Qmax is equal to Vf into Kj by 4. So you can directly take 70 into Kj is how much, sir? 100 divided by 4. So 7,400 7,000 divided by 4. What is the value, sir? So it will be how much? I think it is 1750 vehicle per hour. Sir, this is related to what, my dear students? This is related to the green shield model, where you have to remember the equation. Okay, where you have to remember the equation. But let me tell you, Vinay Alvarpu, in a very easiest way. Here velocity is given as how much, sir? U is, or V or U is given as 70 minus 0.7 k, right, sir? Sir, let me tell you, for any function to be maxima or minima, what, sir? For any function to be maxima or minima, its derivative should be 0. Am I true? Very good. So here for a function q max, okay, sir, for a flow to be q max, here you should know q max should be maximum. So you already know that q is equal to k into v. What is q, sir? Traffic flow. What is k, sir? Traffic density. So here I can write this equation as k into 70 minus 0.7 k. Am I correct or wrong? So q can be written as 70 minus 0.k. So q can be written as 70k minus 0.7k. Am I correct, sir? Now for a flow to be maximum, its differentiation should be 0. For a flow to be maximum, its differentiation should be 0. So here it is 0.7 k square, sir. Okay, sorry. So what is the differentiation of this value? 70k. Differentiation of k is 1, k square 2k. So 70 minus 2 into 0.7 into k. My dear students, here there is a k into k is k square. So if you solve this, k can be written as 70 divided by 1.4, that is equal to 50. So at a flow where the density is equal to 50, the flow is maximum. Now calculate the velocity at 50. So see, velocity is given by 70 minus 0.7 k. So for q to be q max, means for a flow to be maximum flow, k is equal to how much, sir? K is equal to kj, or you can say k is equal to 50. Very good, Vinay. So V is equal to what, sir? 70 minus 0.7 into 50. When I have done that, you can check it in the previous slide. Here it is k square, sir. I have done that. Okay, very good, Vinay. So here if I substitute it here, 70 minus 0.75, it is equal to 35. Now my dear students, you have to understand here clearly that the maximum traffic flow is equal to here k into v, because you have calculated k is equal to 50. You have the flow as maximum. Similarly, what is the value, sir? You got velocity as how much, sir? 35. So 50 into 35 will be equal to how much, sir? 1500 into 1750 vehicle per hour. So my dear students, I have given you both the ways of solving the problem. I have done with the linear shield model and I got the same value, which is equal to 1750. Here I have done the problem with the other way, then it is also 1750. Vinay Alavarpu, is this clear, sir? Any doubt in this? Is this clear, sir? Any doubt in this methodology? I have given you two methods, sir. Okay, very good. Now my dear students, please try to read this question. It is these are the values related to, or this is a problem related to what, sir? Airport correction. So please read this problem carefully, my dear students. So please read this problem very carefully. Okay, sir, I have given you enough time, students. Now see, students, there was a question here. The question is, a runway is constructed in a new airport according to the Indian International Civil Aviation Organization. The elevation is 535, temperature is 22.65, and they have given you the length of the runway required is 2000 meter, considered effective gradient as 1 percentile. Within the framework of applying sequential corrections as per ICO, the length of runway corrected for the temperature is. Now see, students, here you should be able to understand the correction for temperature they are asking after doing the correction. So let me tell you, there should be, in a proper way, you should solve the problem. Okay. So correction for elevation, if I talk about you, correction for elevation is, the correction for elevation here is, it is 7% correction for an elevation of every 300 meter. Sir, what sir? The correction is 7% for every 300 meter. Agree? Now, my dear students, they have given the elevation as how much, sir? They have given the elevation as 535 meter. Yes or no? So, for 300 meter, the correction is 7%. For 500 meter, what will be the correction? So, it is very simple, sir. So, this is the correction for elevation. So, 500 divided by 300 into 7. So, what will be this value? Can anyone tell me, sir? If you solve this, 500 by 300 is around 1.66 into 7. So, this value will be around 12.48 percentile. So, how much percentile you should give, sir? You should give a value of how much? 12.48. Okay. So, the length of runway is how much, sir? Is given as 2000 meter. Am I clear, sir? So, first you have, see, remember my dear students, very important point. If you want to do the temperature correction, without doing the elevation correction, you cannot move forward, because the sequence you have to follow. After doing the elevation correction, then you have to do the temperature correction. So, here it is what, sir? 12.48 correction for elevation. You can write here, correction for, here you can write it as correction for elevation. What is the correction for elevation if I ask you? 12.48. Sir, when sorry. Sorry, that's a good question, sir. I have seen it wrong. Okay, sorry. Yeah. This is how much, sir? This is how much we have taken? They have taken 535, right? Very good question, sir. It is a typo error, sir. So, change it to 535. Okay, when you just change it to 535 meter. Okay, so it is 535 by 300. And if you do this, you will get 12.48. Okay, actually that value is for 535 only. Okay, sir. It's a typo error. So, if you do this, you will get 12.48 percentile, sir. Okay. Now, 12.48 by 100 into 2000. Okay. So, you will get a value of 249.6. Okay, sir. How much you will get, sir? You will get a value of 249.6. Now, see, what will be the corrected length, sir? What is the corrected length here? What is the corrected length here? The corrected length is 2000 plus 249.6. So, it will be 2249.6 meter. Okay. Sir, is this clear, Amma? It's a typo mistake I have done. It is for 535. Not only, it is not like 500 meter. I have just seen. Okay. Now see students, we have to do the elevation correction. Temperature correction. Sir, always remember, without doing the elevation correction, you cannot do the temperature correction. So what is temperature correction here? What is the temperature correction, sir? It is given as, very good, sir. Temperature correction is given as 15 minus 0.0065 into H degrees centigrade. Okay. So here, what is the value, sir? This will be equal to 15 minus 0.0065. It is the, what is the elevation H? What is the elevation they have given? They have given the value as 535 meter. What, sir? They give the elevation value as how much, sir? 535 meter. Now, what is the value you will get? What is the value you will get, sir? Sir, what is the value you have got? Can anyone tell me? By doing this, what is the value you will get, sir? You will get a value of 11 point, how much you will get, sir? 11.52 degrees. Now, to do temperature correction, sir, actually we have two formulas. Let me tell you. Sir, what is the correction here is, they have given the, see, the elevation and the airport reference temperature is how much, sir? 22.65 degrees. What, sir? You got, they have given ART. What, sir? ART means what, sir? Airport reference temperature. What, sir? Airport reference temperature is given as how much? They have given airport reference temperature as, how much value they have given, sir? 22.65 degrees. How much they have given? Airport reference temperature, it is 22.65 degrees. Now, what is this 11.525 degree? Can you tell me, Vinay? Sir, this is called the SAT. What, sir? Actually, this is called not temperature, means, I'll tell you. What is SAT, sir? Standard atmospheric temperature. Now, my dear students, what is temperature correction is? It is the difference between airport reference temperature minus standard atmospheric temperature. Are you getting me, sir? So, if here if I do temperature correction, here I do temperature correction. Here if I do temperature correction, it is equal to ART minus SAT. ART is how much, sir? 22.65 degrees. SAT is how much? 11.52 degrees. I am taking up to 2 decimals when I, okay? It can be up to. So, if you do here, it will be 11.13 degrees. The temperature, okay? Now, see students, for every 1 degree, this is a note, sir. For every 1 degree centigrade, the change in is 1 percentile. What is the change, sir? 1 percentile. So, for 11.13 degrees, what is the change, sir? 11.13. So, if you do the correction here, elevation correction, you can take up to roughly 2250, sir. Because we got a value of 2249.6. Roughly, we can take approximation as 2250. Okay. 2250 divided into, what is the correction we got, sir? 11.13 divided by 100. Sir, 11.13 percentile, right? Plus, this is the correction, sir. This is only the correction. Plus actual 2250. Sir, if you do this again, this correction value also you will get 250 meter. And if you add to the correction after elevation, it is 2250. The final answer you will get it as 2500 meter. What is the final answer you will get, sir? 2500 meter. And when after this, most of the people will forget to do this check. Always remember, sir, The check here is elevation correction. What, sir? This is a very important point, sir. Elevation correction plus temperature correction. Elevation correction plus temperature correction cannot be more than 35 percentile. Sir, what is 35 percentile of 2000? It is 700, sir. Here it is 500. So it is less than. So the check has passed. Are you able to understand, sir? Let me tell you, if you see the order in the airport correction, sir, first we will do the elevation correction. After doing the elevation correction, we will do the temperature correction. Elevation correction is for every 300 meter, we do a correction of 7 percentile of the total runway length. Here they have given 535 meter. Based on that, we have calculated the value and we got the correction. Similarly, what we have to do? We have to do the correction for temperature after following the elevation correction. So what is temperature correction, sir? It is the difference between the absolute airport reference temperature minus the standard atmospheric temperature. So to find out the standard atmospheric temperature, it is equal to 15 minus 0.0065 into H, where H is the elevation. After finding the temperature correction, we have done the correction for with respect to what? With respect to the elevation. Sir, what is the mistake people will do? They take the 2000 value and they do the problem. Then it is a mistake. So by doing the elevation correction, for that correction, we do the temperature. So the sequence is also important. But after doing these two corrections, this should not exceed how much, sir? This should not exceed 35. If it exceeds 35%, sir, what I have to do? So in that case, you take the 35% of the entire and do that. The direct answer will be 2700. Okay. So let me do, please solve this question, students. I will give you this question. Please solve this question. I will give you 2 minutes of time. Okay. Hello, my dear students. I hope you are following the question. So please read the question carefully, sir. Very good, students. So here, my dear students, let me tell you the basic things here. The question, we have done the corrections for what, sir? We have done the correction for elevation. We have done the correction for temperature. Now, what is the other correction we have missed out for airport is the gradient correction. What is the gradient correction? Now, what is the effective gradient of the runway? If they ask you, the longitudinal section of a rainfall data follows this, sir. 0 to 300 meter, what, sir? 0 to 300 meter, it is 1.2%. And 300 to 600 percentile minus 0.7. Now, my dear students, let me tell you the very easiest method which I am following. Okay, sir? Again and again I am telling you this is the easiest method where you can follow. So here 0 to 300 it is how much, sir? 3.6, right, my dear students? So see, sir, what is the percentage? If they ask you, it is 1.2%. So what is the height in difference between them? 0 to 300. The difference is 300. So what you can do is 1.2 divided by 100, because it is in percentile, into the elevation is how much, sir? 300. So you will get a value of 3.6. So first value you will get how much, sir? 3.6. And here also what is the difference, sir? 300 meter. So again 300 by into 0.7 is how much, sir? This value will be equal to minus 2.1 percentile. How much, sir? Minus 2.1 percentile. So this is how much, sir? Difference. 600 and 1100 is how much? 500 percentile. So this value will be equal to how much, sir? 3 percentile. Yes or no, my dear students? And what is the 1100 to 1400? This is 300. And if I do the percentile here, it is how much, sir? Minus 2.4 percentile. Sir, actually we are getting the slope, that is the, they are giving the height, they have given the percentage. So we are gradient. So we are, next, this is also 300. So 300 into length, minus is, minus, you can say, minus 3 percentile. So these are the values according to their lengths. Now what I have to do, sir? I have to take the cumulative values. What I have to do, sir? Are you following, my dear students? You have to find out the cumulative values. When I hope you are clear, sir. What is the cumulative values here? It is, this is how much, sir? 3.6 positive. Here it is minus 2.1. So 3.6 minus 2.1 is how much, sir? It is 1.5 percentile. So 1.5 plus 3 is how much? 4.5 percentile. 4.5 minus 2.4 is how much, sir? 2.1 percentile. And 2.1 minus 3 is minus 0.9 percentile. Okay. Now, my dear students, what is the gradient correction? Let me tell you. What is the gradient correction, sir? Gradient correction will be taken as RL of highest minus RL means here we can say reduced level, sir, or you can say height. RL of lowest upon the length. So can anyone tell me what is the value here? Can anyone tell me what is the value, sir? Please do that value and tell me what is the answer there. Sir, see, what is the length here? They have taken from 0 to 1700. So what is the RL of highest? If you see the cumulative, what is the highest, sir? Highest is nothing but 4.5. Highest is how much, sir? Nothing but the 4.5. This is the highest value. What is the least, sir? Least is 0.9 percentile. Am I correct or wrong? So here, if you see here, the RL of highest is 4.5 minus of minus 0.9 into percentile. If you consider here, you should multiply with 100, sir, into 1700 into 100. So it will be equal to 5.4 divided by 17. So what will be the average value? It will be 0.317, I think. It will be equal to how much, sir? 0.317 percentile. Am I clear, my dear students? So here always remember, this is what, sir? This is the gradient correction. Sir, let me tell you, see students, what I have done here also. Here see, here I have done very good things, sir. I have calculated the lengths, I have calculated the gradients. You have to find out what, sir, this length, whatever the gradient into length and whatever the gradient into length. Then we have to do the cumulative part. Okay. So please write down this, students. If you have any queries, you can ask me. Please write down that. Very good, Vinay. Very good. That is the final answer we got, sir. Very good, sir. Now, see, sir, can anyone solve this problem? Next question we have. when I try the problem before I am explaining, Amma, if you know the concept, that will also help you. Sir, see, the question is a car is traveling at 60 km per hour. Okay. A car is traveling at how much, sir? 60 km per hour. Read the question and try to solve the problem. Very good, sir. I have given you enough time, Amma. A car is traveling at a speed of 60 km per hour on a section of a highway having a downward gradient is how much, sir? Downward gradient. See, students, first of all, you should understand what is downward gradient and what is upward gradient. This is the upward gradient. Sir, see, in ascending gradient, or you can say it is the upward gradient, means climbing up. Sir, in ascending gradient, we take it as positive. First of all, you should always understand, if the gradient is ascending gradient, we take it as positive. Okay? I hope you are clear, my dear students. Similarly, if I take it as descending gradient, okay? If I take it as descending gradient, it will be taken as what, sir? Or down gradient. Then we will take it as negative. Then we will take it as what, sir? Descending gradient is taken as what? It is taken as negative. Agree, sir? Very good, sir. Now see, students, a car is traveling at a speed of 60 km per hour on a highway having a downward gradient is how much, sir? 2 percentile. So, downward gradient n is equal to how much, sir? You can write it as minus 2 percentile, or you can write it as minus 0.02 if I take 2 by 100. Okay, I hope you are clear. Next, the driver of the car observes a stopped vehicle on the car path at a 130-meter head and applies a brake. He sees a car at what, sir? 130-meter ahead. If the brake efficiency is how much, sir? What is the brake efficiency? Brake efficiency is given as 0.7 percentile. Okay. Efficiency is given as 6, sir. 0.6. Brake efficiency is given as 60 percentile, means 0.6. Coefficient of friction is how much, sir? 0.7. The driver's reaction time is how much, sir? 2.5 seconds. The distance required by the car to bring the car to a safe stopping site. Sir, let me tell you here. What he is asking here is, he is asking the stopping site distance. What, sir? He is asking the stopping site distance. What is stopping site distance? Let me tell you. Always remember, sir. Okay. What is stopping site distance, sir? Stopping site distance is nothing but the summation of lag distance plus stopping site distance is what, sir? Summation of lag distance plus braking distance. Stopping site distance is nothing but summation of lag distance plus what, sir? Braking distance. Now you can ask me, what is lag distance? The lag distance is nothing but the distance traveled during reaction time. The distance traveled during reaction time. So, if I take velocity and t, this will be your lag distance. Okay. Now, what is braking distance? Sir, actually there is a formula, means there is a concept behind it. Work done to stop the vehicle is equal to what, sir? Work done to stop the vehicle. Work done to stop the vehicle is equal to, what is work done to stop the vehicle is equal to what, sir? Work done to stop the vehicle is equal to kinetic energy lost. What, sir? Work done to stop the vehicle is equal to what? Kinetic energy lost. So here, based on that, actually some of the students, I am telling this equation also, sir, actually coefficient of friction into weight into distance, braking distance is equal to kinematic. Sir, here it is half mv square minus 0 when it is dead stop condition, sir. Are you getting me? Here if it is not dead stop condition, there will be V1, V2. That is the reason I am telling this concept here. So by this, if you simplify that, in a sloping side, braking distance is given as 2G into F efficiency plus or minus N. Are you getting, my dear students? Sir, this is braking distance. And what is lag distance, sir? Lag distance is V into T. And this reaction time according to IRC code is always 2.5 seconds. Always it is almost, sir, 2.5 seconds. Now, what is braking efficiency is actual coefficient of friction upon, it is the maximum coefficient of friction into 100. What is the efficiency, sir? Actual coefficient of friction upon maximum coefficient of friction. Sir, what is N? N is here the downward gradient, okay. So, downward gradient, if I take N, it is negative, or you can say I told you descending gradient. And N is positive in case of what, sir? In case of ascending gradient. Sir, if the questions, if you are liking this session, please like the session and try to share the session to the maximum student so that it will be benefited for them. So here, see students, here velocity is given as 60 km per hour. So you have to convert into meter per second. So 60 into 5 by 18 will be your meter per second. Into reaction time is how much, sir? Reaction time is 2.5 plus same thing, braking distance 60 into 5 by 18 whole square. This is what, sir? V square upon 2G, 2 into 9.81. This is the gravity. And what is the friction, sir? Friction is given as 0.7 into 0 point efficiency. So for this, this is F, this is N, this is G. Okay, I am writing here for your understanding. VT minus 0.02. So what is the answer you got, my dear students? What is the answer you got, sir? Sir, please check it. You will get an answer of 77.1 meter. So 16 into 5 by 18, 300 by 18. Have you got this answer, sir? You will get an answer of, okay. I hope you are clear. Everyone got the answer? Very good. Now read this question, sir. Sir, please read this question, everyone. very good, sir. Here, see students. Actually, they are asking what is the length of the summit curve. First, let me tell you the length of summit curve. If L is greater than SSD, we have to assume, sir, there are two formulas. When L is greater than stopping side distance, the length of the summit curve is given by the formula ns square upon root 2h plus root 2 small h whole square. Okay, sir. Here what actually is n? Here n is the algebraic difference between the grades. What, sir? If suppose both are positive, always remember it is means you have to take the sign into account. Algebraic means you have to take sign into account. Are you following, my dear students? So n is equal to g1 minus g2. So n, it is nothing but the algebraic difference between the gradients. It is the algebraic difference between the gradients. I hope you are clear. Now what is h, sir? H is the height of driver What is small h, sir? Height of object. And what is S? S is the stopping side distance. So this is how. Sir, let me tell you, this formula is applicable when L is greater than S. Sir, if the standard, usually height of the object, height of the driver will be 1.5 or height of object will be 0.15. It is taken as ns square upon 4.4. Okay. Similarly, if L is less than SSD, then the length of the summit curve, is given by the formula what, sir? It is given as 2s minus root 2h plus root 2h whole square upon n. Sir, there will be a question asked from all the students. Sir, whether we have to use case 1 or case 2. Sir, this is like assumption. Suppose if I follow the first case problem. Sir, I have used the problem with the first formula. Now I have calculated SSD, and if your length of curve is not more than SSD, then your assumption is wrong. Then you have to go to the second case. There is no other way. It is like you have to assume the first case and you have to do, if it is greater than, so that is will be the answer. If it is not greater than, go to the second case and it will be always less than. So it will be accept in that case. If it is one case is not there, it should accept the other case and you will get the answer. Now here see students. Now vertical, sir, read the data. I have given you the concept here. A vertical summit curve on a Frighten corridor is formed at the intersection of two gradients, 3 and minus 5 percentile. Assume the following: only large side trucks are allowed on this corridor. Design speed is how much, sir? 80 km/h. Eye height of the driver above the road. This is the, I told you, no, capital H is the height of the driver. Height of the object above the road surface while trucks needs to stop is 0.35. So height of the object is how much, sir? 0.35. The reaction time for the truck driver is 2 seconds. Coefficient of longitudinal friction is 0.3 seconds. Now, sir, see. First I will find out SSD. First what I will find out, sir? SSD. SSD will be equal to Vt plus V square upon 2GF. Now people will ask me, sir, there are given two gradients, which gradient? So no need to consider the gradient, just calculate the value of SSD. Sir, what is the value of SSD here? Sir, they have given velocity is how much, sir? 80 km/h. So it is 80 into 5 by 18 into time is how much, sir? 2 seconds they have given. And V square is how much, sir? Again 80 by 5 by 18 whole square upon 2 into 9.81 into coefficient of friction is how much, sir? Coefficient of friction. Coefficient of friction they have given as how much, sir? 0.35 thing. 0.36 into 0.36. So it will be how much, sir? They have got the value of stopping side distance as 114.47 meter. Let me check it. This is 18,404.5 into 22.4. 22.22 into 2, 45, 484, 70. Yeah, you will get a value of 114.47 meter. Yes, sir. Okay. I hope you are following. After that, see students, to find out the length of the curve, we are assuming L is equal to ns square upon root 2h plus root 2h whole square. N is equal to algebraic difference between the grades, that is 3 minus of minus 5. This is equal to 8 percentile. So this will be equal to 0.08. So here L is equal to 0.08 into S square is 114.47 whole square divided by height of the driver is how much, sir? Height of the driver is 2.3 and height of the object is how much, sir? They have given us height of the object above the road surface is 0.35. 2.3 and 0.35. So 2.3 plus root 2 into 0.35 whole square. Again I am trying, this is the height of driver. For your understanding I am giving you students. What is this, sir? Height of the driver. What is this? Height of object. So what is the answer you got, sir? After solving this, how much answer you got? You will get a value of around 117.93 meter. Length of summit curve if you do, you will get a value of this. So what you can see here, if you compare these two, now L is greater than SST. Whatever you have calculated, that is greater than this value, right? So our assumption is correct. So our assumption is correct. Are you following, sir? Any doubts in this? Any doubts in this, students? Are you clear or not? Any doubts in this, sir? Sir, we have taken L length of summit curve is ns square upon root 2h plus root 2 small h whole square. Am I clear or not? Please write down that, students. If you have any doubts, please ask me, sir. Now see, students, there is another question here. Please read this question, students. I'll give you 2 minutes of time. Sir, see, read the question and please consider the key takeaways from the problem, sir. Okay. Please read the question, sir, here. Okay. Now see, students, a car is following a slow moving truck on a 2-lane. The car reduces its speed from 10 meter per second to follows the truck maintaining a distance of 16 meter. On finding a clear gap in the opposing traffic, the car accelerates at a rate of 4 meter per second square. While it returns to the original line, the distance between the car and the truck is 16 meter. The total distance by the car during the period leave its lane and subsequently returns to its overtaking. Now see students, they are asking actually there is a overtaking side distance, sir. Let me tell you some concept here before going to the problem. So what is overtaking side distance is, here if I talk about overtaking side distance, it is d1 plus d2 plus d3. Okay sir, what is d1 plus d2 plus d3 is, okay, suppose see my dear students, if you have a vehicle here, when it tries to cross, there is another slow moving vehicle here. Okay, see students, this is the vehicle which you want moving fast. This is the slow moving vehicle. So once you realize it that I want to overtake that vehicle, in that time you will move here. From here, you will come here. Okay, now there will be at the same time, there might be another vehicle which is coming in the opposite direction. So here what is OSD, sir? OSD is nothing but D1 plus D2 plus D3, in which case, in a two-way traffic. What, sir? In a two-way traffic. Okay. So this is one will be D1. Whatever this entire space will be D2 and this will be D3. So for your understanding, I am telling you, sir, what is D1, D2, D3. And let me tell you, in C, D1 is equal to what, sir? VB into T. And let me tell you, reaction, this T is what, sir? Reaction time. And reaction time for OSD, if they ask you, is 2 seconds. What is the reaction time, sir? The reaction time is how much? 2 seconds. Okay. Similarly, if I talk about D2, it is VB into capital 2 plus 2S. Okay. Now tell me, sir, in this problem actually they have asked only D2. They have not asked the OSD. Sir, here they have asked you only D2. What is D2 is distance traveled during overtaking operation. Sir, please be clear. What, sir? Distance traveled during overtaking operation. And sir, see, if you talk what is V and what is VB. Sir, here V is the velocity of fast moving vehicle. V is the velocity of, I hope you are following, sir. V is the velocity of fast moving vehicle. And what is VB, sir? VB is the velocity of slow moving vehicle. Velocity of slow moving vehicle. Okay. Now, velocity of slow moving vehicle can be taken as what, sir? Velocity minus 4.5 meter per second. What, sir? Velocity of slow moving vehicle can be taken as velocity minus 4.5 meter per second. So here we have overtaking operation period. What is T? This is equal to, actual formula is 2 into spacing S1 plus S2 divided by A. Sir, if the spacings are equal, you might have studied as root F4S by A. When do we use root 4S by A? If the spacings are same. When do you use 4S by A, sir? When the spacings are same. So T1 plus T2, here you have to take, this is the formula. Now what is D3, sir? D3 is nothing but V into capital T. Now see students, here we have S. What is S? S is nothing but, sir, in ideal capacity, in traffic, we have derived this, sir. Spacing between the vehicles is given by the formula 0.7 VB plus L. Now what is L, sir, here? L is nothing but what, sir? Length of wheelbase. What is L, sir? Length of wheelbase, which is 6.1 meter. So see students, they can ask you, OSD for two-way traffic is what, sir? D1 plus D2 plus D3. Okay, and let me tell you what is D1, my dear students. After giving the equation, it is VB into T. And what is D2? VB into capital T plus 2S plus what is D3, sir? V into capital T. And remember, VB is equal to V minus 4.5. T is equal to root over S1 plus S2 into A, or V L is equal, sorry, S is equal to 0.7 VB plus L, and the length of wheelbase is how much, sir? 6.1 meter. This is the formula for what, sir? This is the formula for what? Two-way traffic. Now, in this problem, what they have asked is, they have asked only D2, sir. They have asked only D2. What is D2? Distance travel during, D2 is nothing but distance travel during overtaking operation only. What's the distance travel during overtaking, distance travel during only overtaking operation only. Am I clear, sir? Sir, you can write here, what is D2? Distance travel during the overtaking operation only. So here if I take D2, as I told you, VB into capital T plus what, sir? 2S. D2 is what? VB into capital T plus 2S. Now see students here, what is the spacing between the vehicles they have given, sir? What is the spacing between the vehicles they have given? What is the spacing between the vehicles they have given? They have given it as 16 meter. Sir, their acceleration is given as how much, sir? A, it is 4. Now the velocity of the vehicle is given as how much, sir? The velocity is given as how much, sir? 10 meter per second. And it is also a slow moving trike. The car reduces to 10 meter per second. So see students, here VB is given as 10 meter per second. And spacing between the vehicles is given as how much, sir? 16 meter. Now both the sides spacing is same, sir. So here what you have to do, time is equal to 4S by A. So time is equal to, I hope you are following, students. So 4 into 16, retardation is how much, sir? 4. So 4 into 16 divided by 4. So 4 cancel. So time period is equal to how much, sir? Time period is equal to how much? Time period is 4 seconds. Agree, sir? Now what is D2, sir? What is D2? So you know VB is how much? 10. Overtaking operation is how much? 4 seconds. Spacing is how much? 16 meter. So 2 into 16 meter will be considered as 72 meter. So the final answer here is how much, sir? 72 meter. So I have given you the in and out concept of this. So if you see the solution here, what is the answer, sir? Answer is B, that is 72 meter. Any doubts in this, students? So we will move on to the next question, sir. Sir, please read this question. Okay. So see students, please try to read the question here. Okay. The question here is, please read the question. In a Marshall method of mix design, the coarse aggregate, fine aggregate, fines and bitumens have respective values of specific gravity 2.6, 2.7, 2.65 and 1.01. Okay, are mixed in the relative portions by weight of 55, 34.8, 3.7, 5.5. The theoretical specific gravity of the mix and the effective specific gravity of the aggregates in the mix respectively are. So see students, actually let me tell you some small thing about this concept, sir. Sir, whenever I talk GT, this we call it as theoretical specific gravity. What, sir? Theoretical specific gravity. Actually, what is theoretical specific gravity is, okay sir, suppose if we consider here, okay, layers in the soil, sorry, pavement, we can consider this as coarse aggregate, fine aggregate, filler, bitumen, and this as voids. Okay sir. So if I take here, this one is W1, W2, W3, WB, and weight of voids will be negligible, so I will take it as 0. Similarly here I will take G1, G2, G3, specific gravities. What is this, sir? G1, G3, G2 are the specific gravities. Okay. Similarly we can take it as volume of coarse aggregate, V1, V2, V3, VB, but volume of voids will be there, sir. Okay. Now see students, theoretical specific gravity means unit weight of substance by unit weight of water. Anyhow, unit weight of water will be taken as what, sir? 1 gram per cc. So you can write it as weight of substance by volume of the substance. Yes or no? Now see students, on deriving this you will get, if you do the derivation part, okay sir, weight of the substance means add all the things, okay. If you do this 100 upon theoretical specific gravity, it will be getting as W1 percentile upon G1 plus W2 percentile upon G2 plus W3 percentile upon G3 plus weight of bitumen upon GB. You will get. Clear, sir? This is the formula for what? Theoretical specific gravity. Okay. Now see students, if I talk here, what is the values they have given, sir? Sir, now see. Now let me tell you about the theoretical specific gravity. Now what is GT? 100 divided by, now what is their values given, sir? First one is 55 percentile. So weight by G1. G1 is how much, sir? Specific gravity is how much? 2.6 plus next one. What is the weight, sir? 35.8 divided by, what is this value? 35.8 divided by 2.7 plus W3, weight is how much, sir? 3.7 divided by 2.65 plus, what is the weight of bitumen, sir? Because coarse aggregate, fines and bitumen. 1.01 divided by 5.5 divided by 1.01. So now please solve this and tell me what is this value, sir. What will be the theoretical specific gravity? What you have got, tell me. Sir, if you see roughly, I will tell you, sir, this is 20, this is around 15, I think, 35, this is around 36, that is 41. If you do this theoretical specific gravity, you will get a value of around 2.42. What will be the theoretical specific gravity, sir? 2.42. Agree? Is this clear, sir? Is this clear for everyone? Now, what they have asked, sir, the effective specific gravity of the aggregates. What they are asking? The effective specific gravity of aggregates. The effective specific gravity of aggregates. So, aggregates are two things, sir. What are those two things? One is the coarse aggregate and other one is the fine aggregate. Suppose if I have taken weight of coarse aggregate into specific gravity of coarse aggregate, weight of fine aggregate, let me write you weight of coarse specific gravity of coarse aggregate, weight of fine aggregate, specific gravity of fine aggregate upon weight of coarse aggregate plus weight of fine aggregate. You can say weight of fine aggregate. Yes or no, sir? So, weight of coarse aggregate is how much, sir? First we have coarse and fine, right? 55 and 35.8. So, you can write 55 plus 35.8. Here also 55 plus 35.8. Okay. Now, what is the specific gravity of coarse aggregate and fine aggregate? It is 2.6 into 2.7. So, if you do this value, what will be the value, sir? What will be the effective specific gravity? So, if you do the effective specific gravity, it will be around 2.63. It will be around what, sir? 2.63. Sir, please check these things. This is what theoretical specific gravity, this is the effective specific gravity. Sir, when I talk here effective specific gravity, we are taking, they have given only for the aggregates. As they have given only for the aggregates, we are taking the coarse aggregate and fine aggregate into account. I hope you are following. Please write down this. Now, see students, we have another thing. This is related to Marshall stability analysis, sir. Now, the question here, please try to read the question. I'll give you 2 minutes of time. Okay. Please solve that question. Now, see students, in a Marshall sample, the bulk specific gravity of the mix of aggregates are 2.324 and 2.546 respectively. The sample includes 5% of bitumen by total weight of specific gravity 1.1. The theoretical maximum specific gravity is 2.44. The void filled with the bitumen in the Marshall sample is. Sir, see here it is simple, amma. Voids filled in bitumen they have asked. Sir, what is voids filled in bitumen? Sir, voids filled in bitumen is given by the formula VB upon voids in mineral aggregate into 100. Okay, sir. Am I clear, sir? Very good. So, what actually is VMA, voids in mineral aggregate? VMA is given as VB plus VB percentile upon VB percentile. Now, let me tell you, sir, VB percentile is equal to GT minus GM by GT into 100. So, what is GT? What is GT, sir? Theoretical specific gravity. What is GT? Theoretical specific gravity. What is GM, sir? Mass specific gravity. Agree? Similarly, if you talk about VB, WB percentile into GM by GB. Now see students, here what is VB, sir? GT is how much? Theoretical specific gravity is how much, sir? In Marshall, the bulk specific gravity of mix and aggregates are 2.324 and 2.546. The sample includes the theoretical maximum specific gravity is how much, sir? 2.44. So, theoretical specific gravity is 2.441. Okay. And the mass specific gravity, now, in a Marshall speak, the bulk specific gravity of the mix and aggregates are how much, sir? Okay. What is the mass specific gravity? Can anyone tell me? Sir, see, here the theoretical maximum specific gravity of the mix is how much? 2.441. Now, in a Marshall, they have given the sample includes 5% of weight of bitumen, okay? And they have given the specific gravity is also how much, sir? 1.1. So, GB is equal to how much? GB is equal to 5 percentile, okay? And they have given 1.1, sir, sorry. GB is 1.1 percentile, weight is 5 percentile, okay? Now, what we have done, theoretical specific gravity is 2.441. The bulk specific gravity of the mix and aggregates. Sir, we want only mix. So, here the bulk means mass specific gravity is nothing but what, sir? It is equal to 2.324. Okay. So, here if I do, what is this? 2.324 by what is GT, sir? GT is how much? 2.441 into 100. So, what will be the volume of voids? Can anyone tell me, sir? What will be the volume of voids? Sir, 44 minus 32 means 0.12. It will be around, sir, please solve that, anyone? 1 second. So, 2.44 minus 2.324 divided by 2.441. It is equal to how much, sir? This is equal to 4.79 percentile. So, VV percentile is how much? You got 4.79. Are you following, students? Now, what is WB, sir? It is 5 percentile. So, 5 into, what is the GB value I told? 1.1. 1.1 divided by, what is the GM, mass specific gravity? Sir, mass specific gravity is how much, sir? The bulk specific gravity of the mix and aggregate is 2.324 and 2.446. Mass specific gravity is nothing but 2.324. Okay, 2.324. So, what is VB? Can anyone tell me, sir? What is VB? If you solve this, see students, you will get a value of 10.56 percentile. Okay, you get a value of VB how much, sir? 10.6 0.56 percentile. Am I correct or wrong? Okay. So now what is VB, sir? Now VFB is equal to what? VB percentile plus VMA percentile into 100. Yes or no? Very good, sir. Now what is VB percentile there? It is 10.56 divided by VMA. What is VMA? VMA is nothing but VV percentile plus, so VV percentile plus VB percentile into 100. So here you can write 10.56 divided by 4.79 plus 10.56 into 100. What will be the percentage, sir? Can anyone tell me what will be the percentage? What will be the percentage here? This percentage will be equal to 68.78%. What will be the percentage, sir? This percentile will be equal to how much? 68.78%. So my dear students, when I ask you about mixed design, sir, see, when I ask you about mixed design, first theoretical specific gravity. What is the formula for theoretical specific gravity, sir? It is given by the formula 100 upon W1. Sir, are you following? Please try to respond in the chat box, live chat. W2 percentile upon G2 plus W3 percentile upon G3 plus weight of bitumen upon specific gravity of bitumen. So this is what, sir? GT. Agree, sir? Similarly, if I talk about mass specific gravity, okay? Sir, we have mass specific gravity also. They will be giving this. Now, mass specific gravity can be also taken as weight of mole. Now, VV percentile can be taken as GT minus GM by GT minus GT into 100. Okay. Now, see students, volume of bitumen percentile is given as WB percentile into GM by GB. This is VB percentile because WB is in percentile. Similarly, VMA, voids in mineral aggregate, is, you can write it as volume of voids. Very good, Elegana case. VV plus VB. Next, VFB. Voids will be in bitumen is nothing but volume of bitumen upon voids in mineral aggregate into 100. So these are the things which you should understand, student. So here what is the thing, sir? This is GT, right? This is VV. Okay. And this is VMA. And these are the formulas for VFP. Are you clear, students? Okay. Now let me tell you some other concepts related to super elevation, extra widening and all, students. Sir, see, if anyone asks you what is super elevation, this is the basic term in transportation, sir. What is super elevation is, always remember, sir, super elevation, the basic term is the rise of outer edge of the pavement. It is the rise of outer edge of pavement. It is the rise of outer edge of the pavement with respect to horizontal. What, sir? It is the rise of outer edge of the pavement with respect to horizontal. Suppose if I consider this as a pavement, this is the rise of outer edge. That is the reason, see students, outer edge will be at higher usually. Okay. Again, in railway engineering, you come across the concept of negative super elevation. Leave that. Now see students, you already know centrifugal force, right sir? What is centrifugal force is, if you talk about centrifugal force, P is equal to mv square upon r. Okay sir, what is m here? This is nothing but you can write it as weight by g. So P can be written as W by G into V square by R. Or you can write here P by W is equal to V square upon GR. This we call it as centrifugal ratio. What we call, sir? This we call it as what, sir? Centrifugal ratio. Now see students, if I take a vehicle, there can be two chances of failure. What, sir? If I take a vehicle, there can be two chances of failures, okay, mainly. One is the skidding, as you all know, and other one is what, sir? Overturning. Another one is what, sir? Overturning. Now see students, when there should not be any overturning or when there should not be any skidding, then you should understand that for no skidding, F should be greater than P by W. What is P by W? Skid, friction. For no overturning, B by 2H should be greater than P by W. What, sir? This is for no skidding. Sir, if it is not greater than, then skidding will happen. Or here you can say no overturning. Okay. So these are the two important things you should very keep in mind, sir. How this B by 2H came, let me tell you. If I consider this as a vehicle, sir, usually weight acts at center. And we consider this is the B. And centrifugal force P acts at H. If we equate the moments, then it will become as B by W is equal to B by 2H. Okay, that is how it comes. Now see students, actually if we consider in case of mixed traffic, what, sir? Sorry, first we will discuss about the equilibrium superelevation. First see, sir, the general equation of superelevation. The general equation of superelevation is E plus F is equal to V square by GR, or if you talk about velocity in kilometer per hour, then it will be equal to what, sir? V square upon 127 R. Then it will be equal to what, sir? E plus F is equal to V square by GR, or you can write it as V square upon 127 R. Now see students, actually this formula, if you do be specific, actually it will be 1 minus E plus F into 1 minus EF into V square by GR. Actually this is the actual formula, sir. But actually E into F values will be very small. So we are neglecting this. Okay, sir. Usually see students, the maximum value of, if you consider the maximum value of super elevation, it is equal to 7 percentile in case of planes. Sir, always you have to design the super elevation taking into account the maximum value and also minimum value. Why minimum value, you can ask me. Sir, the minimum super elevation is taken into account to counter the camber, because whatever the water which is falling, it should be drained off. So that is why, that is the reason you should also keep in mind the camber into account. So you always have to check the maximum values and minimum values. Minimum value is for the check for camber. Okay. Now similarly, my dear students, if you talk about the maximum value of coefficient of, sir, if you talk the coefficient of friction in a stopping side distance, the coefficient of friction in stopping side distance is what, students? It is related to what, sir? Stopping side distance, coefficient of friction is related to what? Longitudinal friction. Here it is lateral friction, and the maximum value is how much, sir? 0.15. Okay, and let me tell you, if they give you equilibrium super elevation, what, sir? If they give you equilibrium super elevation, what, sir? If they give you the equilibrium superelevation, remember my dear students, in equilibrium superelevation, you can take F value as 0. What sir? In equilibrium superelevation, what you can do? You can take the F value as 0. But similarly, in case of mixed traffic also, sir, you have to take E is equal to 75% of the velocity only, 0.575 V whole square upon GR. Or you can take it as what, sir? You can take this value as V square upon 225R. What, sir? V square upon 225R. Clear? Now, similarly, my dear students, let me tell you, there are two things. One is the extra widening. Sir, usually, when there is a curve, we provide extra widening, sir. So, what is extra widening is? Extra widening is taken as, it is the summation of mechanical widening plus psychological widening. What, sir? It is the summation of mechanical widening and psychological widening. Here, mechanical widening means it is taken as N into L square by 2R. Sir, this L square by 2R is, we call it as off tracking. Sir, if anyone asks you, my dear students, what do you mean by off tracking is, it is the deviation of the front and rear wheels. What, sir? It is the deviation in the front and rear wheels. And what is psychological widening? Plus V upon 9.5 root R. What, sir? V upon 9.5 root R. And remember, sir, usually when the radius is less than 50 meter, we provide on the inner side. If the radius is between 50 to 300, we provide on both sides. But let me tell you, when the radius is greater than 300 meter, there is no requirement of extra widening. What, sir? There is no requirement of extra widening. I hope you are clear. Sir, here my dear students, if you see here the velocity is in what units? Kilometer per hour. Here what is N, sir? N you can ask me. Here N is nothing but what? Number of lanes. What is N, sir? N is nothing but the number of lanes. If I talk about number of lanes, how to calculate they can give you. Suppose if this is a road, sir, they can give you the width of the road. They can give you the width and they can ask you what is the number of lanes. Suppose, see, usually for multiple lanes, how do we calculate? N is N into 3.5 is equal to width. Based on this relation, you will get the number of lanes. This is for multiple lanes. For single lane, they will give you 3.75 meter. Okay. Now, similarly, my dear students, if I talk about transition curve, actually transition curve is introduced between a straight line and where the curve has been started. Sir, in transition curve, let me tell you two important things, sir. The length of the transition curve is given by the formula V cube upon CR. Okay. V is in meter per second. Here, what is C, sir? Rate of change of acceleration. What is C? C is nothing but the rate of change of acceleration. And here C can be taken as 80 upon 75 plus V kilometer per hour. Okay. And V can also be written as length of transition curve, En into W plus WE. Okay. This is another formula. If it is rotated about inner edge, if it is rotated about outer edge, En by 2 into W plus WE. Or another formula is what, sir? 2.7 V square by R. Now, see students, this is an empirical formula. If it is rotated about center line, then En by 2 W plus WE. What is N, you can ask me? Rate of change of superelevation. What's the rate of change of superelevation? Sir, these values are 150 in case of planes and 60 in case of hills. Okay, you have to remember this. Now, out of these three, which will be the length of the transition curve, sir? Which will be the length of the transition curve? You can say the maximum value of these will be the length of the transition curve. And similarly, if they ask you what is shift of transition curve, similarly, if they ask you what is the shift of the transition curve, shift of the transition curve is nothing but LS square upon 24R. Actually, shift of transition curve means how a circular curve can be, how a transition curve can be converted into a circular curve. So, my dear students, if you are really preparing for GATE exam, honestly, then I will tell you in some basic things, my dear students. Geotechnical, transportation and environmental are the key subjects where you have to score good marks, apart from maths and aptitude. And let me tell you, with the new IITs and with the new NITs, even with a rank of 3,000 and 4,000, I have seen in the last year, there are high chances to get into IITs. So if you have lose your hope in your plus 2 or PUC or intermediate, then you have a high chance to convert and to be a brand of IIT. Means you can get that brand of IIT will give you a lot of career opportunities, especially for the core branches like civil, mechanical and electrical. So my dear students, if you want to boost up yourself or if you want to practice more and more, we are coming with a test series plus app. Sir, in this test series plus, it is not about only testing yourself. Sir, in the test series, we are providing 12 test series, that is all India mock test. In addition to this, we are providing 130 plus tests, which covers chapter test, subject test, advanced level test, multiple subject tests. In addition to this, we are also giving you the most premium product, that is 33 years of previous year GATE solutions. And wherever you find difficult level, those questions are recorded and you can see the access through the scanner, okay, where you can scan the QR code and you can access those videos in the book itself. In addition to this, we are also providing the doubt solving. Suppose if you are having any challenges in the tests or if you are having any doubts in the previous year questions, the doubts will be also answered. Now, my dear students, related to online revision or post-GATE guidance. Sir, let me tell you, the post-GATE guidance is very important in nowadays. As I have informed you, there are various IITs, various NITs and all. Now, what we do at IMS GATE Academy? My dear students, we at IMS GATE Academy offers offline GATE coaching, online GATE coaching, and also we are providing 33 plus years of GATE solution, previous year GATE solution. In addition to this, we are giving you the online test series, and this also contains like 12 test series, and we have advanced level test, multiple subject test. We are providing the offline GATE coaching at Jayanagar, Bangalore, and also at Vijayawada and also at Malleshwaram. We are into the online GATE coaching. We are also providing the hybrid model. And my dear students, the key success, if you talk about the key success, if you talk about the IMS GATE Academy, is the My Plan sessions. We monitor the students right from the first day of preparation to the after the completing the GATE exam, still applying the GATE exam, applying the colleges like post-GATE guidance. So my dear students, if you have any queries, definitely you will have high chances to getting enrolled for the IITs only through three principles: learn, practice and test. So if you are really testing yourself, then Test Series Plus is a very important tool where you can brush up all your things. I hope, see students, if you want to really test, and let me tell you, my dear students, in these sessions in Great Score Boosters, you name geotechnical and transportation, if you can brush up your previous activities where revision plays a very vital role. In transportation especially, we have traffic engineering is the most subject where you have to look into it. If you talk about airport corrections, geometric design, super elevation, transition curves, or stopping side distance, or overtaking side distance, or valley curves, summit curves. Similarly, I have touched the Marshall stability analysis where we have voids of bitumen, voids filled in bitumen and all. So that is also a serious question which is waiting. I can say in the last 2 years we have not seen a question for Marshall stability. We can expect a theory question or we can expect a problem. Now what we do at in this telegram is, for any daily quizzes, we will be posting daily questions. In addition to this, we are also providing the PSU job notifications and all. Now my dear students, if you are looking for seriously into the Test Series Plus, the link is provided in the description and you can fill that form and you can get the details of the test series plus activity. I hope these sessions will help you to understand and to brush up your things. And let me tell you, my dear students, in the next week, Saturday and Sunday, I'll be coming live again on the Gate Score Booster series related to the subjects RCC and Geomatics. I hope you have enjoyed this session, and please share this session if you like, and try to practice these problems, my dear students. We have covered different quality of problems and different section of problems where all the topics can be revised. I hope this session is helpful. Thank you.